Welcome back to this channel, and in this video I'm going to be clearing a misconception about the general formula that we all know, that we have been taught from, in fact, at secondary school, right? Which is, if you're given a function y is equal to x raised to power n, then we are all taught that dy by dx, basically, at Niger. So we have this, but there is something not complete yet. We need to add that this whole thing is multiplied by when you differentiate x. This is what you should learn, you should write. Now, the purpose of dx now might not be visible for a polynomial function because it seems like normal, but when we get to trigonometric identity where we have to solve, the likes of sine, tan, and the rest, it's so obvious. So let's take a look at an example. Let's take an example. Suppose you have to solve y is equals to 4x squared, right? Of course, the y over dx will now be what? 4 as a constant will remain there, times my n, which is 2, then x raised to power 2 minus 1, and I have to still differentiate x. If I should differentiate x, that's 1. Okay, so the y over dx will now be what? 8x times 1. So y prime is what? 8x. All right, so be like, so what's the difference? Let me show you what the difference is now. Suppose we have a question in a trigonometrical function, right? Let's move this to this side so we can keep on to view it. Let's say we have a question like this. Suppose you are given y is equals to tan square of, let's say, maybe 5x. I want to differentiate this function. You can also write this as y is equals to tan of 5x all to the square. Okay, so in this case, you see that the whole of this 5 tan 5x is your x, and this 2 is your what? Is your n. All right, so you follow this formula we just wrote here, which means that y prime will now be n, which is my 2, then my x raised to power n minus 1, which is 2 minus 1, then times dx. So this is my x. How do I differentiate that? So I'll just say that this is 5 sec square 5x. That's my dx. So bringing everything together, I would have 2 times 5x raised to power 1, so I can still leave it that way, then times 5 sec square 5x, right? Then in general, I would have 10 sec square 5x than what? Than 5x. So you can see the importance of modifying the formula by adding this part of the equation. So next time you are writing this equation, always have this in mind, so that when you get to some functions with power, basically functions with constant powers, you can always, because this n is a constant basically, so when you get to functions of constant powers, you can always have it in mind and not to be confused. So I will leave you with an exercise. You can go to the comment section to let me know what the answer would be. If possible, you can snap and send your solution. So using the concepts, what would the derivative of sec square 4x, what will it be? Then what will the derivative of 6, let me say the sine of 3, then 2x over 5, what would that be? So I'll be expecting your answers in the comment section, and once again, don't forget to like, share, and most importantly, don't forget to subscribe to this channel so you can get more videos subsequently, and I'll see you in the next video.